All right, we just quizzed on solving one-step inequalities. Similar to chapter 2, instead of solving one-step equations, we started solving multi-step equations. Now we're going to be solving multi-step inequalities. So it's very, very similar to chapter 2, except now with an inequality instead of an equation. I'm going to try and make this as fast as possible. However, I like math a lot, and I get very passionate about it. And I like math. I like talking about math. And so if I get sidetracked, I apologize, but I'm going to try and make it as fast as possible for you. So we're solving inequalities that have more than one operation. We're going to solving and graphing inequality. Again, very similar to what we did in chapter 2. We are going to work backwards through PEMDAS. We're going to do snoit to repo for redrow. We're going to work backwards through PEMDAS. And so we're going to minus 6 from both sides first. We're going to use we're going to deal with any adding or subtracting first. We get negative 18 is greater than or equal to 3x. We're going to solve for x. We're going to divide both sides by 3. Since we divided by a positive number, we keep the symbol the same. Negative 18 divided by 3, we're going to get negative 6. So we've solved the inequality. We can now graph that inequality. At this point, we should be getting very good at graphing. So negative 6 was my solution. We count in the correct direction. We go further away from 0 as we go to the left. X is less than negative 6. Well, I know that negative 4 is greater than negative 6. So if x is less than negative 6, I'm going to go in that direction. And x could equal negative 6. So I fill in my circle. Same thing with one down here. And if you want to pause it and work faster than me, feel free and then check your work. I'm going to get y by itself. Remember, we're not going to do plus 8. 8 plus 8 is not 0. We want this to become 0. So I'm going to minus 8. 8 minus 8 is 0. I'm going to minus 8 from the other side. 29 minus 8 is 21, greater than or equal to, and this minus 3y is still a negative 3y, or a minus 3y. So that minus sign stays with the 3. Don't forget about that. It's been a little while, some of you made that mistake before. We need to remember that the negative stays with the 3, or if you prefer, and you don't like what I just did there, use your keep change. Now it's a negative 3y. Either way, it becomes a negative 3y down here. I'm going to solve for y. I'm going to divide both sides by negative 3. And I divided by a negative number. If I divide by a negative number, I have to reverse that. I have to do the flip and the flop and the flippity flop. I've got to flip that inequality around. And I get y is less than or equal to negative 7. I can then graph that solution so I can show all the possible answers. Again, with the negatives, be careful of your counting. We got negative 8, negative 9. This says that y is less than or equal to negative 7. Again, I know that negative 9 is less than negative 7. I close in my circle. So solving just like we did two-step equations, except it's a two-step inequality. A few more things to remember with the flipping of the sign. But as long as we can work slowly through those problems and be careful of every single step, show your work so you know every step you're taking. We got 2 more here, or another 2 here, I guess. Fractions. Now again, when you have more than one thing inside of a fraction, it's like having parentheses. So you can go ahead and put parentheses there, you can go ahead and put parentheses here. We're going to solve for x, so we do that inverse operation. We're going to deal with parentheses last. Remember, we're working backwards through PEMDAS. I can't get my D, that's right, DAS, there we go. We're going backwards through PEMDAS, we deal with the parentheses last. So I do times negative 2, times negative 2. 3 times negative 2 is negative 6, and I still have the x plus 5 over here. But don't forget, if you multiply by a negative, you've got to flip that sign around. Now I'm going to get x by itself, minus 5 from both sides, and x is less than negative 11. Graph my solutions, negative 11, negative 10, negative 9. There we go. And x is less than negative 11, but x will never equal negative 11. Same thing on the one over here. We've got parentheses, so I deal with that last. I'm going to multiply both sides times 3. I get 1 minus 2n. I multiplied by a positive number, so I leave the symbol alone, 21. Now I'm still solving for n, so I need to go backwards through PEMDAS. I need to get rid of this 1. 1 minus 1 is 0. 21 minus 1 is 20. There we go. And I have this negative 2n left over. So negative 2n. Divide both sides by a negative 2. I divided by a negative, so I flip the sign over. And I get negative 10 as my solution. So n is less than or equal to negative 10. I can then graph that solution. Negative 9, negative 8, there we go. And n is less than or equal to negative 10. Give these two a try. See what you can make of these two. I'm going to assume that you paused it. I'm just checking my time here. Assume that you paused it, tried it on your own. Let's solve it. Let's take a look. So we've got parentheses. Now, most of you, hopefully, if you remembered, distributed first to get rid of those parentheses. And that works. And I'm going to do that first. I'm going to show you a different way to see which way you prefer. So if we distribute first, we get negative 8 plus 4x. Negative 4 times 2 is negative 8. Negative 4 times negative x is a positive 4x. And so we get positive 4x less than or equal to 8. I then add 8 to both sides. There we go. I get that 4x is less than or equal to 16. Divide both sides by 4, and x is less than or equal to 4. Again, I'm hoping that you tried it once on your own. You can always pause it, rewind, go slower. So I'm going through the problem a little bit quicker. There is another way. There is another way. Let's look at this in a slightly different way. If we look at the problem, move it over here. If we really take what I told you to heart, if we really do it exactly the way I told you to do it, and we work backwards through PEMDAS, which is what I've been telling you to do, we should deal with those parentheses last. This is negative 4 times parentheses 2 minus x. Let's forget about the parentheses. We're going to forget that the parentheses are there. Even though I'm covering it up with my hand, you can't tell, but I'm going to cover up the 2 minus x in parentheses. If it's times, I could divide. I could divide both sides by negative 4. As long as I'm dividing the whole side by negative 4, I'm not breaking any rules. The whole side is being divided. So if I'm multiplying by negative 4 and I divide by negative 4, it's like those cancel away to 1, because negative 4 divided by negative 4 is 1. So we're left with 2 minus x. And since I divided by a negative, greater than or equal to negative 2. Now I get x by itself. I'm going to minus 2 from both sides. Get that negative x is greater than or equal to negative 4. And I don't want to know what negative x is. I want to know what positive x is. So opposite of x is positive x. Opposite of negative 4 is positive 4. And opposite of greater than is less than. Sure enough, exact same answer. Two ways to do it. Both are correct. Both are wonderfully perfect. If you want to do either one, as long as you're communicating and showing your work, I am all for it. Let's check the next one. PEMDAS, right? I have no parentheses to worry about. However, I do have this exponent here, 5 squared. Let's figure out what 5 squared is. 25. So I'm going to simplify that problem as much as I can first. Can't combine any like terms, but I can simplify. I'm going to deal with my adding or subtracting first. So 2m greater than 20. I'm going to divide both sides by 2, and m is greater than 10. Now I realize I didn't graph the top one, but we've done enough graphing that I'm going to assume that you can do that one on your own. M is greater than 10. 9, 8. If m is greater than 10, my arrow is going to go in that direction. 11 is greater than 10. 12 is greater than 10. But m will never equal 10. Fractions, one word problem here, and then you'll have some to try on your own. So with fractions, same process, right? We're going to do the inverse operation. Opposite of plus is minus 1/2. I'm going to minus 1/2 from both sides. 1/2 minus 1/2 is nothing. So I have 2/3 f greater than. I don't have common denominators, so let's go with sixths maybe. So I'm going to times 2. I get 2/6 minus times 3 there. I get 3/6. 2/6 minus 3/6 is 1/6. Those are the lisps, but sixths. So we've worked with our fractions there. Now we've got a fraction, 2/3. It's 2/3 times f. So the inverse operation would be to divide both sides by 2/3, which is exactly correct. We can divide both sides by 2/3. But remember, when you divide both sides by a fraction, you are going to have to take the reciprocal. You are going to have to flip that fraction over and multiply. So let's take a shortcut. We thought a little bit harder, and we took a shortcut. If I multiply 2/3 times 3/2, I'm going to get 1 whole, 6/6. So I'm going to have 1f left over. 1/6 times 2/3, if I do some cross-reducing, which you certainly don't have to do, I'm going to divide both these by 3. I'm going to end up with 1/4. You could certainly have multiplied straight across and gotten 3/12, reduced it to 1/4. Either way is correct. So f is greater than 1/4. And I'm going to graph it. Now you can definitely do a decimal if you want, but I'm going to go with fractions since I have it. 1/4, 2/4 is 1/2. 3/4. Yes, we still need to reduce, even if we have fractions, or if we're graphing, we still need to reduce. 0, and then I'd have negative 1/4. Okay? F is greater than 1/4, and it will not equal 1/4. Last one here. Not quite as short as I'd hoped, but last one here. Average of Jim's 2 test scores. Oh, this is a good one, yes. Average of Jim's 2 test scores must be at least 90. So again, at least 90. It's okay to have a better than 90. Greater than 90 is okay. Less than 90 would not be okay. And so at least 90 means that it's going to have to be more than 90 or exactly 90 to get an A in the class. Jim got a 95 on his first test. What grade can he get on a second test to make an A in the class? Ooh, average. A couple ways to find average. When they talk about average in this chapter, I'm going to go ahead and tell you they're talking about the mean average. The mean average means we add them together and divide by however many values there are. So we're going to take 95 on his first test plus his second test. We don't know what his second test was. Oh, well, let's use x. There we go. We have a variable for that. And we divide by however many tests there are. 2 tests. 2 tests. So again, we got this part right here because if you add the 2 tests together, 95 plus whatever, and divide it by 2, because there's 2 tests, we'll get the average. And we know that that average needs to be greater than 90 or at least 90 or equal to 90 to get an A. We have an inequality. We can solve an inequality. It's like having parentheses. It's almost like we've done these. Times 2 times 2. 95 plus x is greater than or equal to 180. If I minus 95 from both sides, minus 95 from both sides, I'm going to get that x could be greater than or equal to, what is that going to be, an 85? 180. Now, let's see, does it say the graph? I don't think it does. No. So what grades can Jim get on his test to make an A in the class? He can get a grade of anything greater than 85. He can get an 85, a 6, a 7. Now, we don't know if his teacher does half points, so we don't know if there could be decimal percents. We're not sure exactly. And so x could be greater than or equal to 85 points on his next exam. Okay, yep. Here you go. We got 4 questions. It's hard to get the pictures just right, so if you can't read the pictures very well, please look in the book. The online book is out there as well. Page 191, 21 through 24.